Hey there, STEAM cadets, and welcome to this explainer. I'm Professor L, head mentor of the STEAM universe, and I'm absolutely thrilled to welcome you back to the Engineering Command Center. Now, in our last mission, we figured out how engineers communicate their brilliant ideas using professional engineering drawings, right? Well, today, we're facing a brand new challenge. We need to decide which design actually deserves to become the final security system for the CNE Ajanya Community Hub. So today's mission is entirely focused on evaluating our prototype designs before we even think about building them. Go ahead and power up your holographic tablets, grab your workbooks, and let's investigate like real engineers.
Okay, let's dive into this idea. Think about this for a second. Imagine you're saving up your hard-earned cash to buy a brand new cell phone. Are you going to just walk into a store, close your eyes, point at a random box, and buy the very first one you see? No way! You're going to compare the camera quality, check out the battery life, look at the screen size, and, of course, check the price. You investigate, right? Well, guess what? Engineers do the exact same thing. Before we slice a single piece of cardboard or strip a single wire, we have to compare our ideas. We evaluate them to figure out which one is actually going to work best.
All right, here's our investigation checklist for today. First, we'll evaluate the designs. Second, select the best design. Third, improve and problem solve. Fourth, figure out tools and materials. And finally, our mission debrief.
Let's kick things off with Section 1. Evaluate the designs, which tackles question 6.1 on comparing prototypes.
So, Phase 1 of our mission lines up perfectly with question 6.1 in your workbooks. When we evaluate, we don't just guess. No, we use really specific investigation parameters. We call these criteria to measure whether a design is actually going to work in the real world. Let's break down 4 key evaluation criteria across 3 different prototypes in our matrix here. First up, size. Does the housing fit perfectly inside our strict 120 by 120 by 20 millimeter limit? Second, stability. Is the structure strong, or is it kind of going to fall apart in a breeze? Third, electronic components. Are the wires, the LED, and the buzzer locked in securely? And fourth, battery replacement. Can you actually swap out a dead battery easily? You can see, for instance, Design A hits the size constraint perfectly, but it's got really weak stability and loose wires. Comparing data just like this is literally the best way to spot the strengths and weaknesses of any idea in a matter of seconds.
All right, it's time for your very first STEAM Cadet Challenge. I want you to pause and really think about the criteria we just laid out. If you were the lead engineer on this project, which design would you say scores the absolute highest for overall stability and functionality? Remember, you want a design that ticks all the positive boxes. We're talking perfect size, strong stability, secure wires, and easy access to that battery. Think it over independently for a second. Well, if you pick design C, you are thinking exactly like an engineer. And that actually brings us to a super important definition. What does it really mean to evaluate something? Evaluation is simply the process of systematically comparing different designs against specific constraints and specifications to find the best possible solution. It's not about which design looks the coolest or has the best colors. It's entirely about which design follows the rules of the game. For example, making sure your housing fits that strict 120mm by 120mm constraint is non-negotiable. If it's too big, it fails the evaluation. Period. It doesn't matter how amazing it looks. Which brings us to another massive constraint, our power source. Your alarm system prototype has to be powered by a battery pack that doesn't exceed 9 volts, just to make sure it's portable and safe. But here's the real kicker. A genuinely great design has to let the user easily replace that 9-volt battery when it eventually dies. If your client has to literally rip the cardboard housing apart and break the prototype, or, pull out a chainsaw just to pop in a fresh battery, that is a failed design. Easy access is absolutely key.
Moving right along to Section 2, select the best design, covering question 6.2 on justifying your choice.
Okay, now that we actually know how to compare designs, simply picking one is only half the battle. A real engineer has to be able to prove exactly why they chose it. You've got to justify your choice using hard evidence. Let's look at the difference between a pretty weak answer and a perfect model answer. A poor justification sounds a bit like this. I picked design B because it looks good and works well. That tells us absolutely nothing, right? It's just an opinion. Now look at the full marks justification. I selected design B because it meets the 120mm size constraint, has a stable housing, and allows easy battery replacement. Do you see the difference there? That full marks answer uses specific, factual evidence from our criteria to back up its point. That is exactly how you score top marks in your workbook. To help you construct those full mark answers, I highly recommend highlighting these engineer transition words right in your notes. We're talking about words like because, therefore, and as a result, or phrases like meets the specifications or is reliable and affordable. Whenever you weave these keywords in, you instantly build a strong, super logical argument that proves to the examiner you aren't just guessing, you're evaluating based on concrete facts. Next up is Section 3, Improve and Problem Solve. This covers questions 6.3 and 6.4 on upgrades and troubleshoot. All right, I'm going to let you in on a little secret of the STEAM universe. Absolutely no design is ever perfect on the first try. Even the absolute smartest engineers in the world look at their finished blueprints and immediately ask, okay, how can I make this better? Upgrading and troubleshooting are a massive part of the whole engineering design process. So for question 6.3, you need to suggest some realistic improvements to your design. What could you practically upgrade? Well, you could use stronger hot glue instead of stick glue to give it way more stability. You could reinforce the cardboard housing to make it tougher, maybe even waterproof it. You could build a custom, really snug battery holder so that 9-volt doesn't rattle around inside. Or hey, you could just reposition the master switch to the outside of the box so it's way easier to hit. These are all incredibly practical examples you can write down.
Time for another STEAM Cadet Challenge. Let's see if you can anticipate a problem before it even happens. Just imagine you're right in the middle of building your prototype. You've glued the housing together, you've connected all your components, you reach out, flip the switch, and silence. Nothing. The buzzer doesn't activate, or maybe you notice a wire is just hanging loose. What's your immediate next step? How exactly do you troubleshoot that?
Well, for question 6.4, here's exactly how we handle those moments. First off, troubleshooting is totally normal. If you've got loose wires, your practical solution is just to tightly wrap those bare wires together and lock them down with some insulation tape. If the circuit is totally dead and doesn't work at all, carefully check all your connections to ensure everything is actually touching. And if that still fails, just try replacing the 9-volt battery. If your LED isn't visible because it's hidden inside, your simple solution is to cut a small hole and reposition that LED right to the outside of the housing.
I really want you to memorize this quote. Every problem has a solution. This is pretty much the golden rule of engineering. When your circuit refuses to beep or your LED absolutely won't flash, please don't get frustrated. A broken circuit is never a failure. It's literally just a puzzle waiting for you to solve it. Normalizing failure as just another standard step in learning is what makes you a truly great STEAM cadet.
Moving on to Section 4, Tools and Materials. This is question 6.5, heading into the armory.
Before you step foot into the workshop to actually physically build your scale model for question 6.5, you have to list out exactly what you're bringing into your armory. The really crucial thing to grasp here is the difference between tools and materials. Tools are the actual equipment you use to build the prototype. You use them, and then you put them right back in the toolbox when you're done. We're talking things like your scissors, your craft knife, a metal ruler, your glue gun, and wire strippers. Materials, on the flip side, are the items that are totally consumed and actually become part of your final physical product. This includes your structural pieces like cardboard, the insulation tape, melted glue sticks, and whatever recycled plastics you're using for the housing.
And of course, let's not forget, your materials also include your electronic components. You are definitely going to need to list your 9-volt battery, your buzzer for that audible alert, your LED for the visual alert, your light-dependent resistor or thermistor acting as your sensor, and your SPST master switch. Just make absolutely sure your list in question 6.5 is completely comprehensive. If you don't list it on paper, you can't use it in the build.
Finally, our mission debrief, engineering investigation complete.
And just like that, you have successfully navigated the entire investigation phase. Huge congratulations, cadets. You now have all the knowledge you could possibly need to tackle Worksheet 6A with total confidence and precision. Just take a look back at the broader engineering design process. We started off by investigating the core problem. Today, we thoroughly evaluated our designs against our constraints. We carefully chose the absolute best solution based on hard evidence, and we planned out our upgrades and troubleshooting steps. That means we have successfully conquered the first 4 steps of this epic journey. Mission 008 objectives are officially achieved. You seriously should be incredibly proud of yourselves. You aren't just guessing anymore. You are actively investigating, comparing, and justifying your designs using real evidence and critical thinking, exactly like professional engineers do out in the field. You're guaranteeing that your Siakanya Community Hub alarm system is going to be structurally sound, perfectly sized, and highly functional. Which leaves us with just one final, very exciting question. Now that you've evaluated your options, justified your ultimate choice, and gathered all your tools and materials, are you finally ready to construct and test your very own prototype? Because that is exactly what we're going to tackle in Mission 009. Gather up those blueprints, STEAM cadets, because it is time to bring your incredible designs to life. Keep learning, keep creating, and always keep innovating. I'll catch you in the next explainer.